Welcome to my talk about full-stack application with open source technologies. My name is Matthias Zimmermann. I come from Switzerland, work for BSI Switzerland. I'm one of the co-leads of the Eclipse Scout project. And the reason we can do this here is basically with the Scout framework. We changed to a full Java platform last year, so we stepped down from the OSGI platform, just became a normal Java application framework, which can combine nicely with other things. And as I'm Scout project lead, of course, it's kind of, at some place there has to be Scout in the talk, but basically it's more about the general open source stack, and Scout is in it. And the reason for this is the talk we had last year at the same location, with Scout moving to HTML5. So let's have a look at the agenda. First, we look at the application stack goals for such an application. Then we have an overview of this demo task application. We look a bit at Spring Boot. We look a bit at Eclipse Scout, the two components. We look how they use from a beginner's perspective is the hello world, and then have a look what's the difference to the actual task app, this demo app. Then we do a demo, basically the generic stuff of business applications. You have to add fields, you have to add business logic, and so on. And I want to demonstrate how you can do that with this open source stack in a fairly short time. Finally, there's a wrap-up. So the goals for this application stack I'm going to demonstrate. First and mostly, it's to simplify the life of the developer. And secondly, it should also allow for large and complex applications. So it's a stack that is not just meant for baby examples, but the stack is meant to scale to mid-size or even large applications without the need to really change a lot of technologies or even any technology. You just can keep the technologies that are presented here, even for larger business applications. And very important, especially for this type of business applications, the stack should provide long-term sustainability. The reason for this, we frequently observe, also from a commercial side, applications we build, they live for 5 to 10 years in production. So if you're not careful by selecting your technology stack, you're sooner or later in the situation where you have one or more or even several legacy technologies inside it, and some developer took something in because it was nice at that time, then he went to another employer, and nobody really knows it anymore, so you just have to keep, and you end up with a technology zoo. So the idea, the beginning idea of this stack is to take care from the beginning that you're not going into this technology zoo direction. Basically, it's about the right tool for the right job. The requirements for such a stack is, this is just what we propose for this application stack, is Java as a platform. And why? Mostly because sustainability. We can reasonably expect that Java is here still in 10 years. And we still have the possibility to find many developers in the space and acquire them basically from the street, and they would know about Java. So this should not be a bottleneck of it. And the open source part is, again, sustainability. So basically, you try to be not in a commercial space, but try to be in an open space where you have a reasonable expectation that the frameworks that you use, they're still here in 5 to 10 years, or if they go away, at least you have long enough head notice to switch to some other parts that would replace the functionality that you have originally used in that area. Then, proven in practice, if you build systems that go into production, the last thing that you want is when you move to production that your small system is going to explode while the load is increasing or while use cases become more complex than originally anticipated. So there are only technologies in that stack that have been proven in practice over many, many years. And finally, it's also an idea to try to reduce the number of frameworks and components, technical components that are involved in the stack to an absolute minimum. Because if you don't really tender carefully to the number of external dependencies that you have, it just significantly increases the risk of having legacy technology dependencies sooner or later. So the more focused the stack is on the task, so the lower is the risk that by chance running into some legacy corner here and there. And obviously, if you do that, you have to take care that you update your dependencies. You manage basically all your dependencies during the lifetime of the application. So the overview of the stack, let's start at the database level. We propose to use the PostgreSQL database, which is really robust and can do more complex things than MySQL if you want. It's not that this is good for everything, but it's really proven in practice. There are tons of people understanding good enough how to manage such SQL servers and how to work with SQL stuff. Then on the service and the persistence side, we're proposing to use the Spring framework. That is basically connecting to the database and to the layers above. And for all the presentation stuff, basically the building of the UI logic and things like that, we would like to propose to use Eclipse Scout, which is on the presentation part is all Java. So basically the Scout developer is writing Java code, but the consumer is actually using the application from the browser. So it's a real HTML5 application that the user is actually working with. Let's have a quick demo at this task application that we use to demonstrate the stack. There is, here I can have my link. I go log in, I have an Eclipse Scout user, Eclipse as the username, Scout as the password. I log into the application. And then basically in the morning, I have an inbox, I see what I should do. Oh, I need to buy milk. Bob was assigning that job to me, and I should do this today, but I'm kind of short on time, so I open this and say, no, sorry, Bob, it's you. Have time today, sorry. So it goes away from my inbox, I do something new and say, but I have to present up stack about Spring and Scout. And this is not in my inbox, but it's one of my today's tasks. And this is one part of the application, basically from the user perspective. Maybe there are other applications around that want to consume what I've done inside of my application. So as I'm managing tasks, it would be nice to have a REST API where I can see what the tasks are and what attributes they have. So one of the nice things about Spring is you get that part almost for free. So there's also a REST API here, so I can have all the tasks. If I do this now, I get the 2 tasks listed. I can also search for ID, and it should be this one. Basically, this is one of the 2 tasks IDs. If I put it here, I get access to that particular task over that API. Okay, so let's go back to the slides. This we have seen. So basically, the idea is to have something like a database, some model for the business objects, some user interface, but also a REST API. And the task that the application should demonstrate how to do this in a simple way that is still extensible and powerful enough for larger applications. I want to start with Spring Boot. First, there's a little hello world for Spring for those that never worked with Spring. I'm a Spring newbie, so this did add value to me. I hope it also at some point might add value to you. I don't know about who has never worked with Spring before. Well, at least it's not only me. Cool. So let's do this one. Why Spring Boot? Spring is really strong for server-side programming, and it has been there in the space for many, many years. And a little bit younger is the Spring Boot part. The Spring guys realized that Spring is actually really large and complex, and it's at times hard to get into Spring. That's one of the reasons why they came up with Spring Boot. And to their own claims, they claim that Spring Boot is radically faster in getting started experience and a bunch of other things. And the trick about Spring Boot is not only easier to get into Spring, it's also good enough to use in production. So companies like Netflix actually use Spring Boot in production, I've been told. I'm not sure if this has to do with their site going down, probably not, because other companies not having Spring Boot were affected as well last Friday. So I assume it's not related to this technology. And it's actually production ready. This is what I already have mentioned. So it comes, if you enable it, with auditing, health metrics, and all this stuff out of the box, more or less. If you go to their homepage, this is the Spring Boot homepage, you can download the Spring development tools or the Spring IDE. The Spring IDE is basically just a pimped Eclipse IDE. They take the Eclipse IDE, put additional Spring tooling together, and then this is what they ship in the open source space to develop Spring applications. And then you can just create a new application by this new wizard, and I did select Spring Starter Project. Actually, cannot really demonstrate this part of the step because their wizard requires internet connection, and I didn't want to have that in my demo. So I did that step before, and what we're going to see right now is just right after that step is a really empty application. So I go here in my Spring part. What you see here is basically a Maven project with source main Java, resources, and test. It has a POM, and what the Spring Boot POM looks like, it always has this Spring Boot starter parent if it's coming out of the box. And there is one dependency, the Spring Boot starter web in it. I did add this one because this helps to create the web services afterwards. This brings all the stuff which makes it really easy to address the APIs with Spring. And the only class there is actually, so it's a really, really minimal example. If you start with Spring, it's this demo hello world application. It's an application with the main method, and it just runs and provides the class to its own. So this is the thing that the minimal Spring application that you can do. And now I'm going to add the hello world part of that. And for this, I'm going to write a hello controller just next to it. Add a new class. And here I say, I want this to be a REST controller. And then I have to have a method. And here I say I have some request mapping. So I basically map whatever requests come from this dash will be handled by this method. Oops. So that basically should be it. So before I start this guy, I have to stop my demo application, otherwise my port is not free. And here, this I can just start as a normal Java application. And if I go back to this one, I have my hello world from Spring. So this is saying hello world, and it's going through this REST API. So how much about that much about the hello world from the Spring part? Now what you're going to do is look at the Spring parts that we actually use for the task application. They're slightly more complex, but not really a lot more complex. So the main dependency for this is, as we have seen before, it's the same, the Spring Boot Starter Web for the REST API stuff, but it also has the Spring Boot Starter, the data, basically the Spring Data project in it, which allows easy access for JPI and stuff like that. And it has Project Lombok in it. Who has heard about Project Lombok before? Okay, so for those that did not hear about this, Lombok is a project that you can add to your Java application, and it helps you to avoid writing getters, setters, toString, hash code, equals, all that stuff. So it's really nice for fast prototyping. The main reason why it's here is we have heard that if people come from the Spring side, they like to use Lombok a lot, and so we tried to make their experience with this application stack as smooth as possible. But you can easily replace that, but manually writing all the getters and setters. We'll see that just in a minute. Then the tour, what we're going to look at is first is the application, basically the star class, to see how close it is to what we've seen from the hello world. Then we look at the model, basically the task model that we have seen in the application, and the task service. This is an interface to access the tasks, and the implementation for this interface, and the repository that is taking care of the whole persistence to the database, and finally the task controller, like the hello world controller that is responsible for actually providing this REST API then afterwards. Let's switch to the task demo application. And so let's start with the POM. What we see here is we have the same parent as before in the hello world. We have the Spring Starter parent. And we have basically some Scout dependency here, and the Spring Boot dependencies, the starter web.jpa, some testing, and that's pretty much it. Now go to the application. This is the thing with the main method. So it's really, really close. It has basically the same annotation like Spring Boot application here. It imports some additional configurations, but just 2, not many. And this is about how to start up. So basically this whole thing, what this application is running as a Spring Boot application, the whole task demo thing. If we go to the task, we have a model package, and there is this task class. Basically, here we have a annotation that says it's a JPA entity, and there's tons of Lombok annotations, what I mentioned before. So instead of writing getters, setters, and all this stuff, I just can annotate the class with all this, and Lombok is going to basically provide the implementation for all those. So I don't need to write this. Some people like it, some people don't like it. It's easy to replace. What I said is we feel that people from Spring, they like to use it, so we try to do it in the same way. And Spring has an ID, which is a UUID. This is, again, an annotation from the persistence API. And here is one more Lombok, non-null. Basically, this means that that would be a mandatory field. You cannot do something that has null values in that place. And string, this is the name of the task, is the same. There's a bunch of attributes like these ones. You can put data or not put data. And basically, this is all you need to do for such simple attributes. You don't need to implement anything. And as you see here in the code itself, there are all this getter setter stuff. This is not, you don't need to do that. Then from the task, we can move to the interface, the service interface. We have the task service interface. It's kind of pretty simple. It's just collections of get all tasks, get today's task, and you provide the user, so it's going to fetch all the tasks that are assigned to that user, and you have the same for the inbox and the other thing. You can get a single task, or you can save a task. This is just the update mechanism, or you can add new tasks, so this is adding new stuff. The implementation for it is pretty straightforward. What it actually takes, it takes a repository for the persistence. This is an auto-wired thing from Spring. It's kind of like inject, but it has some additional attributes. I think this is here not really important. But basically, with this task repository, if you want to add a task, it first checks, is it null? And then it checks if the task already exists in the repository. If so, it doesn't do anything, because the idea is to add new task and not, I have to switch to the, sorry, my mouse is dead. And finally, you just say the repository, it should save. This makes us look at the repository, which is handling the persistence with the JPA part. And this is really an easy one with Spring. This is what you do for the whole persistence in that demo application. You say it's a JPA repository, and you want to have this method find by responsible. And basically, in the background, Spring is doing a lot of magic and creating that for you all out of this interface. You don't really need to do more. And the JPA repository itself has a bunch of methods that are doing the normal stuff like store and load of stuff. The only thing that is missing in the Spring part is now the REST API, so have a look at this one. It's, as we have seen in the Hello World part, it's again a REST control on that class, so my task controller, and it has a request mapping on the class itself that goes like, there's a service path initially, which just says /API, and it continues with /tasks. So all the methods I have inside here, they extend the task thing. So if I'm directly on the task, I'm going to show all tasks. And if I provide this parameter ID, which is then mapped by this annotation here, then it's going to fetch a single task and provide that through the REST API. I think that's about it for the Spring part. We went through all this. Now, we're going to have a brief look at the UI part, the front end for the task application. Eclipse Scout is basically a framework for business applications. It's an Eclipse project, just a normal project, and the strong points of Eclipse is strong for building UIs. And it has an application model. And having this application model makes that the Scout code is actually Scout model code, and through that, it becomes independent of a specific UI technology. This is also a bit about the sustainability. In the Scout framework over the last 15 years, we have seen that we have added renderers for new UI technology, something like between every 5 and 3 years, that we had to add a new one so that we actually could sell our products to the customer and that didn't look old-fashioned. As everything is moving to the web currently, the web world is much more in flux than the desktop world that we had previously, so we expect that the pace of having new UI technologies is currently actually increasing. Maybe, or hopefully, it will boil down in the next 5 to 10 years, but now we feel that like every 2 years or every year, there's the new interesting framework to build some new shiny UI, and this is really not sustainable, and Scout is solving this problem by abstracting away the UI technology. So if you implement your interface, your graphical user interface in Scout, you basically don't care about the UI technology because there's a rendering component that is separate that is taking care of that. So the developer doesn't have to do this. And it comes with multi-device support. So if you build your application, it will work well on the desktop browser, on tablet browsers, and mobile devices. And it's taking into account the very different form factor of mobile devices compared to the desktop browser. And it's proven in production, even longer than Spring. This is because there were Scout versions which did not even work on Java, but that was a long time ago. So basically, that it's programming against the model or configuring against the model. This is the core theme of Scout, which tries to improve productivity of developers. And then it went to Java, then it went on top of the Eclipse platform, it had desktop UIs, it had the Eclipse wrap in it. Then last year, as I mentioned initially, we went from the OSGI platform down to a plain Java project. And now we have this HTML5 rendering engine, and we don't really know what will happen in 3 to 5 years. But for our applications, that doesn't really matter, because if something new is coming up and the demand on the market is for a new thing, we basically keep most parts of the Scout. We keep all the Java parts, but we have to add a new renderer and maintain it. But that is not the project that is using Scout. That's the Scout project itself. This is the Scout homepage if you want to start. So there are some demos, downloads, and Hello World tutorial. And this is what you get when you download the Scout package from the Eclipse servers. It's basically the same like the Spring package. It's of course based on the Eclipse IDE, and it adds some tooling that is specific to Scout. We will see that in a minute. So let's do the Scout Hello World to get a first impression about this one. And I have to again stop here, not to conflict with my next demo. So here to create a new world, this should work offline, so I can just click here and say finish. What is this going to do is a multi-module Maven project that we can see here on the left side. We'll do some processing on it and building the workspace eventually. There are many more classes than with the Spring Hello World. That is the reason why it takes slightly longer than the Spring Hello World. And when I'm here, I give a very brief overview of it. Per default, Scout applications, they have an application server and they have a separate presentation server. So basically, it's kind of the client-server pattern that we had from earlier in the desktop world, which we still have for the web world. So from the Maven module, this top thing, it just has the POM for all the modules. That's not interesting. Then we have the client and the server, and every code that is used in both client and server is in the shared package. And additionally, we have this UI HTML. In this module, this is the renderer part. Usually, this is not project-specific. It's just going to render what you write in Java for the UI. And then for running the stuff in development mode, there is a module here for the app server, and a module here for the presentation server. So I basically can start the development server and the presentation server for the development thing. And then switch to a browser. And as we have two applications running, the server is on 8080 and the presentation thing is on 8082 by default. So this is now connecting to the UI server, and it's fetching the CSS and all the JavaScript packages that are provided by the the GUI server, and while it's there, it starts to build up the user interface. And if I click here, I have my hello world. So here, the only thing I want to add is one more text field here. And let's see how we do this. This is inside of the client part. Inside of the client part, I have something like the desktop class. This is the class that is really the thing that you see in the browser. And we're not really looking at this one because they're kind of, if I go here, I have outlines. So basically, this is a page, a hello world page. And the hello world page that you can see over there is in the hello world package. And inside of the hello world page, the only thing this one is doing is basically said, I have a detail form, and if there is a detail form specified, it will show the detail form if I click on this node. This is what is happening here, and the detail form is called hello world form, and finally, this is the form here that is actually displayed on this side. And if I look at that class, the hello world form, then if I look at the imports, then I can see there is no import that is related in any way to a UI technology. These are just plain abstract Java classes provided by the Scout framework, nothing else. So the rendering part, basically the rendering to the mapping to the HTML stuff, all that is in the UI HTML package and not in the project usually. And inside of the hello world form, I have something like a view handler that is taking care of lifecycle management. So if the thing is loading, it's going to fetch a service. It's called hello world service. And it says this service load, and it gets a form data. Basically, this is the data transfer object between the presentation server and the application server. Once this is here, it just says, map all the fields to my form. So this is automatic data binding that you get out of the box with Scout. Let's look at this service. The service is actually running on the application server and not on the presentation server. So the implementation for this service is actually not in this module, but rather in the server module. And here I find my hello world service class. It's going to implement the service that you have seen on the client side, and this is the definition of the load method. It's basically doing this hello and then your login name, whatever. So instead of having this one, we can do something different. We can say here, hello Ludwigsburg, so that we have the same thing as we have in the case of the Spring thing. And now, let's go back to the client and add an additional field. How we do that? We go to the client, we go to the form. Inside of the form, all the graphical components are inside of the main box. This is a container box, basically an abstract group box. And here we see the message field. So below the message field, I want to have another field. And let's say I want to have the server time. Basically, I want to see in the UI what the time on the server is. And for this, I say a date field. So I write date and use content assist, control space. And this is some of the tooling provided by the Scout SDK. It's providing me a date field here. I say this is the server time. I go to the next field. Here I can choose either just a date field, or in that time, I also want to have the time, so I say abstract date time field. And here, this is the method get configured label. Basically, here I return the text that is supposed to be the label for my new field. And I say I want to have server time here to be displayed. And as we don't like the programmers to write labels inside of the code directly, there is multilingual support. Control space, I can say I want to have a new text here, and then I get a text editor. So what this is doing is basically replacing what I've written before with the key, and it's going, per default, it's going to write the translated text into property files. But in Scout, everything is a service, so you could replace that and read out the translation from a database or from some external source. This is just for convenience, so it's quicker to set up. And having this done on the client, if the form comes up from the server, it will not have any data. So I did not yet provide any data, so I need again switch to the application server and add that to the implementation of the load service, that I get actually some data into this field. So I go back to the hello world service, and I have access to my data transfer object, like input, get server time. It doesn't find it. The reason for this is I did not yet save this one. If I save my form here, it realizes that it has also to update the data transfer object because I have some new value field on it, so it's automatically updating the data transfer object that I have here. So if I do this again, get service, I now have get server time here. So this is done behind the scenes by the Scout SDK, so you don't have to take care about all this fiddling with data transfer objects. And you set value, and you just provide a new date object. And then we'll see how this went. Restart the server, restart the client. And what we should see now is this guy is realizing that there's a new version of the application, so I have to reload anyway. And if I click here, I should have now two fields. I have my message. It now says hello Ludwigsburg. This was the first change, and it also have this server time with the current time. The reason why this field looks different from this one is layouting of the UI. So per default, a group box has two columns, like here's a column and here. And this guy here, the message field, it was defined in the code that it should span two columns. However, in that case, I did not add it. To do this, I would have to go back to the hello world form. And as we can see, the message field has this get configured grid with it returns 2. I don't have this method on the server time field, and this is the reason why the server time field only spans one column and not two columns. So this is basically the demo of the Scout hello world. So we can switch back to the slides. Now we're going to look about the Eclipse Scout as it is used in the tasks demo application stack. Main dependencies is basically this UI HTML. We can do that because the UI HTML package has its own dependencies with our client shared server. And we don't have a server in that case, but instead we need the platform. The platform is something that is below the client and the server. Then the tour through the task demo application. We will see the home outline, which is the main entry point for the navigation. We look at the abstract task table page, basically the class that is responsible for showing the tasks with their attributes for all the nodes. We look at the specific one, the inbox task table page, and the task form, basically the form to create and edit tasks. Now let's switch to the demo application again. So we close the Spring part here. And what you can see here is we go to the UI, and as in the Hello World thing, we have some desktop here, but we have a home outline. This is what I mentioned before. So if I open the home outline, it has one method, create child pages, and create child pages, what it's doing, it's basically has a page list, and it's going to add the inbox, the today's tasks, my task table page, and all tasks table page. This is how it is configured that we see these nodes on the left-hand side in the navigation tree. Now, before we go to look at the inbox table page, we look at the parent class, which is in the UI task package, which is abstract task table page. And again, this is some abstract page with table. It has inside of it, it has a table class, and inside of the table class, it has different things. It has all the attributes that you want to see in the columns. There is an ID column, and the ID column actually you cannot see, but it says that this column is meant to be the primary key, and you never can show it. But it also has the name column somewhere. Where is it? Or title column. Maybe, yeah, this is the title column. And it also has menus. So once you select one or more columns or rows, you can edit that task, or you can add a new task. And these menus are also attached to the table. For example, if you look at the edit menu, this has the edit label, it has some icon, and it's configuring whenever you can use the edit menu. This means the menu types. This line here means that if you want to have the edit menu, it only appears if you have selected a single row. And if you actually do this, the exec action, if you execute it, then this is the code, what you have to do. It's getting the ID column of the selected row. It's creating a new task form. It's setting the task ID, and it says the form that it should modify. By transferring the ID to the form and saying it should modify, the form itself will then go back to the server and load all the data for that task. Okay, so this is about the abstract class. For the table page, now we go to the inbox. Where is the inbox table page here? This is pretty short class. So basically what it's doing here is setting certain columns that you cannot display it, and it's going to fetch the data from the task service to fetch all the data that show in that table. And finally, let's have a look at the task form. Here, it's similar to the Hello World form before, but instead of just having a view handler, this guy has two handlers. One is the modify handler to edit a task, and one is the new handler to add a new task. So if you have the modify handler, then it has two methods, exec load. This is basically fetching the data before the form opens, then mapping all the data that is received from the server to the fields. Then the user is going to edit some stuff, and finally at the end, the user is saving the tasks, and then this is the time when the exec store method is called. And here you define what is going to happen when you want to save the task. So basically, it's again using or accessing the task service, and it's finally saying, save this task. And this export form field data, this is again the mapping of the form fields to the attributes in the task. In contrast to the Hello World, where this is done automatically by form data mapping, here we have to do this manually, because this is basically the bridge from what the fields we have on the user interface to the fields that are provided by the Spring Persistence API, or the modeling of your business object. This is not always the same, so in bigger applications, you always have, at a certain point, there is this place where you have to map what you get from the business services to the actual UI stuff. So not always it's the case, but the business service, they provide attributes to entities that in certain cases don't make, how many? So we're at the end? Okay, so this means that I'm not going to do the final demo. Maybe we can flip through the things. It's a client-only application, what you have seen, not client-server. It has a single Maven module. There's some generic infrastructure to bridge to Spring, and we can use inject instead of this one. Add a field. This would add here a field, and what you have to do is add one line in the Spring part, on the Scout part, one more column. You have to do the mapping between the service and the UI, and the category field to the task form, and also do the mapping here. So wrap up, what have we seen? Combination of Spring Boot and Eclipse Scout, JPA persistence, business model, REST API, UI. And what remains is basically some fine-tuning of the app and documentation on GitHub take-home message. Spring and Scout play along nicely. And only a small set of technologies is needed, and the developer can concentrate on the business value. Thanks. And yeah, don't forget to rate the talk.